Now that we are all revitalized with a fresh pot of coffee, I think that Professor Schlangen is ready to give his presentation on the self-healing prospect for different practical applications. So Erik from TU Delft, please, the floor is yours.
Okay, thank you, Tim. So my talk on the self-healing prospect for different practical applications, well, it represents my own views and not necessarily the views of all the SmartThings partners, so there should be a small disclaimer here. But you will see that we can later discuss if my views correspond with your views. Before I start my presentation, I have to bring some sad news that last Friday we got a message from China that Professor Ningshu Han passed away at an age of 60 years old. Many of you know him. He did his PhD in Delft in the beginning of the 90s, and he worked for 10 more years in the Netherlands at different companies. And then he moved back to China to become a professor at Shenzhen University, where he also was a pioneer for self-healing materials. And most of us met him at conferences and workshops like we have now. So I'm sure he would have liked this talk because I discussed this topic a lot with him, what it means for practice, the self-healing. In this talk, I will be helped with 4 different people that you see here that actually represent myself. One is the owner, one is the professor or researcher, one is a contractor or a construction worker, and one is an advisor of self-healing materials or a salesperson of self-healing materials, as you might know. And I will look at all their views and comment on that when we look at self-healing materials. So we will look at self-healing concrete, why we need it, when we need it, what we need it for, who wants to use it, who needs it, and also where we need it. So I will focus on these points and give you the views of all these 4 people. And I'm happy to work also in these 4 areas before I move to the universities. So I try to share my views on that. First, why? Why do we need self-healing materials? Well, our standard story that we always have at the beginning of a presentation, we need it for durability, to stop ingress of chlorides, to stop corrosion. That's clear. We need it for leakage. If you look to a tunnel, for instance, that you see here, if you have cracks, water is leaking through, we want to stop that. Maybe we also need it for mechanics. Maybe not always, but especially for unreinforced concrete, then maybe we would like to also have strength in our material and want to have that back if you get some damage. And the final one is aesthetics. If you make a structure like this is the Holocaust Memorial in Berlin, where you have these nice concrete blocks, and some of them are heavily cracked, and that doesn't look nice. Or maybe a crack looks nice in this structure, but it's not meant to be there. So for those kinds of reasons, we would like to have self-healing. Then a little bit more in detail, a little bit more specific, why and where do we need them? Well, of course, for nuclear power plants, then it will be clear. Those structures we want to have crack-free, that we don't get radiation coming out, so we don't want cracks there at all. Concrete beams, a bridge, concrete beams in bending. Well, actually, we design concrete structures to crack. So maybe they should be, they should be there. Cracks should be there. Of course, not too big, but maybe we could need some self-healing there. I will come back to that. Of course, if we have pipes for liquid or gas that we especially also store underground, then you don't want cracks in there because then they start leaking, the liquid or gas comes out, and there maybe self-healing could help because they're also difficult to inspect, difficult to repair. Then concrete roads, and especially the unreinforced concrete roads that we usually have. So there we need repair, and there we also need mechanical repair, because if you have a crack of this and it's not repaired, you get no self-healing, then this crack will go further and you will get more and more damage. So here you also need mechanical repair of these damages. Of course, industrial floors or floors at gas stations, there it will be clear that no liquid should leak through the crack to the environment, to the soil, because that is big pollution. So we should prevent that, and in those cases, self-healing would be very nice. And the last one, that's clear one, for tunnels, for reservoirs, for aqueducts, water should stay where it is, should not go through the structure, because then we have a problem. So those are more specific cases where we would need self-healing, or where self-healing materials could help. I don't know if we need them, but it could help there. So that's the opinion of the 4 people. Well, the owner of the structure still asks you why. Why do we have to put in self-healing? We can also solve it in different ways. Of course, the professor, the researcher says, yes, we can do it. We will do it for you. Well, the contractor says, oh my God, what is happening now? Why do we want to put self-healing in our structures? I don't understand. And of course, the advisor of self-healing materials, he will like it if we put in self-healing, that's for sure. But now look at the damage that we get in these structures. Look more closely to all these possible damage cases that can happen with different causes on the material level, on the structural level. So this is a standard picture that you see in a lot of textbooks with all kinds of damage that can happen in a structure. And let's go through them and see if self-healing would be an option there. So the first one, ABC, are related to all these numbers. So I will go through the cracks. So ABC, that's plastic settlement of the material, which happens very early. Excess bleeding, rapid early drying, so 10 minutes to 3 hours after casting. Well, there is a solution for that. Reduce bleeding, put air entrainer, or revibrate, do better vibration. Would you use self-healing there? Well, I'm sure the owner would say, no, 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 no. Don't do that. Come up with a better production way. That's easy to prevent. We don't need self-healing for this. And I agree with that. Well, the second class of damage is plastic shrinkage. So that's rapid early drying, so that the moisture at the surface evaporates and then the material shrinks there. That happens also in the beginning, 30 minutes up to 10 hours. Well, the problem there is if you do no curing, then you can get this. So it's also easy to solve. Improve your early curing and you will prevent this. So also for this, we should not think about self-healing options. So the professor, the researcher will say here, stop thinking about self-healing, no need for that. Then we go to this early thermal contraction. So the problem here is especially with massive structures, or structures with concrete with a lot of autogenous shrinkage. So massive structures, you get a lot of heat generation. This temperature should go somewhere. This typically happens between 1 day and 3 weeks. So you get the heat of hydration that builds up, and then it should cool down, and during the cooling down, in the second week or so, you get cracks in your structure. And of course, here you see a lot of these cracks. If there's water on the other side, they will start leaking, and you should prevent this. There are a lot of options to do that. So you can put a lot of extra reinforcement, but think that the main reinforcement here in such a structure is vertical, not horizontally, where you would need it. So you really should put a lot of extra reinforcement to keep these cracks very small, that they are not start leaking. You can also put in cooling pipes to take away the massive heat that is produced. or use another mix, low heat cement. So there are different options. Also the casting sequence can help you. Different options to prevent these cracks, but they're all quite expensive. So in this case, of course, the contractor, he would like it if you put self-healing materials. He would like it a lot because then he doesn't have to put this reinforcement, he doesn't have to put cooling pipes, whatever, to prevent these cracks. So he would be very happy. Well, the owner doesn't care. He only says, give me a structure without cracks. How you do it doesn't matter, but I don't want cracks. Of course, as a researcher, we say that's a good job if you can put self-healing in here that really closes these cracks and leaking stops. That would probably be a very good solution. And of course, the salesperson of the self-healing agents or the self-healing methods, he likes it a lot because he sees money in there. So he says, awesome. Okay, the next one, the more long-term drying. These cracks that you get after several weeks or months, or maybe years of the age of the structure, where the water slowly evaporates from the concrete, and especially at places where shrinkage cannot happen, where shrinkage is prevented, you get stresses and cracks, especially at these corners here, you see them a lot. So you get cracks there, and they are quite difficult to get rid of or to prevent these. And you would also need a lot of reinforcement there to do that. Of course, the owner, he will not like these cracks, so he wants that they don't appear. The contractor, he says, what should we do there? I didn't design for these cracks. I didn't hope to get these cracks, but they are there. And as a researcher, I would say, okay, this would be a nice opportunity to add self-healing that these cracks disappear. Especially also when it are industrial floors where they use chemicals or gas stations, as I showed, then you would like to close these cracks and prevent leakage of liquids through them. And again, the salesperson, he likes such an option to put self-healing agent because he sees money again. You also have these type of cracks, which are mostly you get them quite early age. They are by impermeable formwork, over traveling of the surface, or mixes with a lot of cement. Well, here you just should improve the curing and do better finishing to prevent these. So this is also not something where self-healing would help you. So the owner says good luck with preventing them. The contractor is not happy with them. Also the salesperson says, I'm sorry, I don't want to deal with this. And the professor thinks, well, if this guy doesn't do it right, then I also don't find a solution. So this should be dealt with in another way. Then we go to corrosion of reinforcement. As I said before, we need cracks in structures. We design structures to crack. So the problem here is that we have often a lack of cover, or maybe we have a lack of excess of calcium chloride in the material. We have a poor quality concrete in the cover. That could lead then to chloride ingress and to corrosion of the reinforcement after some years. Should we use self-healing there? Well, often we say yes, but the owner will say, don't do that because you should just stop it. You should just build in a better way, because according to our standards, concrete can crack, and the crack rate should stay within 0.2 or 0.3 depending on the environment, and then you will not get this corrosion usually. Only if something extra happens, you will get corrosion. So the owner doesn't want to pay for it if you design according to the standard. Also, the contractor will not have money to add something to it to prevent this, because he says, if I build according to the rules, then this will not happen. And of course, we as researchers, we say in this case, it's very good to add self-healing agents to close these cracks and prevent this ingress. And of course, the salesperson, again, he would also like to see self-healing agent in this case. Well, the last class of cracks is the alkali aggregate reaction that you have in structures at 5 years or more, because you have reactive aggregates in there and high alkali cement, and you have water present. Well, in this case, also there's no chance of solving this with self-healing agents. The contractor says awesome, because this usually happens after 10, 20, 30 years, and it's not his responsibility anymore, so he doesn't care. Also, the researcher, he doesn't know what to do, and he is just not happy if I say that self-healing will not work in this case. So, are there some more potentials for self-healing? Yes, there are. Of course, repair. Repair, then something has to be done. And repair is already expensive. And of course, repairs, as we saw before already in the presentation of work package 2, repairs often fail within 2 years. So if you have to repair something, and it is already expensive to do repair, then you can also add self-healing to prevent it from failing again after 2 years. And adding extra cost is also no problem there, because it is already very costly. So then adding self-healing agents in repair material to prevent further damage is a very good idea. Of course, the contractor is not happy with that, because he has to pay for that usually. Or the owner, he has to pay for that. The contractor is super happy, because he also does the repairs, so he will like to come back to repair your structure. Of course, we as researchers, we say we can do it. We can add the self-healing material there, and this guy is laughing a lot because he can earn money. Are there more potentials? We could also leave out rebars. Well, and then the rebars that we put in there for shrinkage, for thermal or drying shrinkage. Because if you leave in only the rebars for the mechanics, that would be enough to make the structure safe. Only then you will get very big cracks, or bigger cracks than that you could have for the regulations, for the standards. So your cracks will be bigger. But if we are sure that we can fill those cracks with self-healing agents, then there is a potential for leaving out the rebars and putting self-healing agents in the concrete. So there's an option there. So the owner will say, oh shit, they found something where they can put it. The contractor thinks it's awesome, because we can leave out many rebars, so it will be much cheaper for him. Well, we say, just a minute. If you do this, you have to be sure that these bigger cracks can be completely closed by self-healing agents. If we are able to do that it works in all circumstances, can fill the cracks completely, then we have a business. But of course, you only have to change the standards in that case, because it's not allowed according to the standards. But that we can do, we can also work on that and then make it available for those cases. And he will be also very happy in that case. Are there more potentials? Well, yes, we saw that Sean Hay in work package 2, he's in Delft, he is working on this topic. So to put self-healing agents only in the cover zone of a structure. Because what you can do there is you can concentrate them where you need them. You can put also a higher dosage so that you are sure that it will work better, because it's only a small amount that you have to put in only this cover zone, so you can put more. And you can cast it, and you can also 3D print it. And also this would work for repair maybe, so you can combine it also for repair techniques. And you can include fibers to make it a material with better properties. So here we see really potentials, and also the owner says, hurry up, we need this. Also the contractor would be super happy with this. We find it a good job, and the salesperson of the self-healing agents, he also likes it. More potentials? Yes, maybe if you could add some extra functionalities for your self-healing agent, and especially in the fresh state. So if we would maybe have it work as an Aaron trainer, or maybe as an accelerator or retarder, that it works maybe for 3D printing also. That it adds some viscosity agent, or maybe some other properties. Because if the self-healing agent has an extra benefit in the beginning, when you make your structure, then everybody will be happy, probably, because then you have something extra with your agent. So the self-healing agent maybe works only at a later age, but in the beginning you also have a benefit. Well, the owner doesn't care, for him it doesn't matter. The contractor will like it. We still have to study a little bit to add these extra functionalities, and this guy, he likes it, of course. Something more, well, you can also just add some extra safety in case something happens, to increase service life, to decrease the risk, to have an extra insurance. But of course, our concrete structures have usually a service life of 50, 100 years. So do we really have to use this as an incentive for adding self-healing materials? Well, the contractor probably is not going to pay, or the owner is not going to pay for it. Also, the contractor doesn't have money to do this. I don't know if this should be really the incentive, and well, for him it doesn't matter. If we put it, then he will be happy, but yeah, we have to see if this is really the good incentive to put self-healing agent. So I'm coming to the end of my presentation, some concluding remarks. So I would say self-healing concrete has a very bright future. If the self-healing method or the self-healing agent is more reliable and or more effective or more cost effective, including maintenance, and or more durable and or more sustainable than traditional solutions, because that's where you have to compare it with traditional solutions. If we can solve it in a traditional way, which is already in the standards, then why not do that? If we do something more, better, faster, more effective, cheaper than with the standard solutions, yes, then we can use self-healing concrete. So, and then we have to put it in the standards too. That is one more thing we have to fix. And that was the end of my presentation. So these guys wish you good luck. See you soon. All the best. And yeah, the salesperson, he is already super rich. Thank you.
Thank you, Erik. A very nice presentation. A few laughs here from the Ghent University side, but I think a very clear analysis. We have not received any questions yet in the chat, but maybe a few of them will pop up in the next couple of minutes.